In this video, we're going to differentiate a function using the product rule. So I've got the product rule written out in this box here, and it just states that if u and v are both differentiable functions of x, then their product uv is also differentiable, and the derivative with respect to x of u times v is equal to u times the derivative of v with respect to x plus v times the derivative of u with respect to x. So if we look at our function here, we've got y is equal to 2 plus 3x squared times 1 minus 3x squared. So if we let this part equal u and this part here is equal to v, so then we have u is equal to 2 plus 3x squared. So the derivative of u with respect to x, that's going to equal, well, the 2 is just a constant term, so the derivative of any constant term is just 0. And then for the 3x squared part, we just use the power rule. So the power of x is 2, so 2 times 3 is 6, and then take 1 off the power, we get 6x. Then we have v is equal to 1 minus 3x squared. So the derivative of v with respect to x equals, well, that 1 is just a constant term, so the derivative of 1 is just 0. And then using the power rule for that minus 3x squared part, we're going to get minus 6x. Then putting everything into our formula, we get dy by dx is equal to u, which is 2 plus 3x squared times the derivative of v, which is negative 6x, and then plus v, 1 minus 3x squared times the derivative of u, which is 6x, and then expanding this out, we're going to get negative 12x minus 18x cubed plus 6x minus 18x cubed. And then we can simplify this a bit, so we're going to get negative 36x cubed minus 6x, and we can actually factor out a negative 6x, so what we get then is negative 6x brackets 6x squared plus 1. Okay, so that's our final answer, and that's an example of differentiating a function using the product rule.